guys, it's Miss Delcambre. Today's Monday, November 2nd, and here's a rundown of what we did today. So you'll need your journal, glue, pencil, and your notes on 8.1. So we're going to go over our week in review. We're going to go over a couple of questions on Builder 10, and then we're going to get into our 8.1 notes. It's 2 pages, guys. And then we'll do our 8.1 homework. I did make some modifications on the homework, so you need to pay attention. So here's our week in review. So today we're going to be doing comparing additive and multiplicative relationships. Builder 10 is our homework for the week. Tomorrow we're talking about ratios, rates, tables, and graphs. Wednesday we're going to be doing solving problems with the proportions. Thursday, I have a meeting off campus for the middle part of the day, or for the last part of the day. So you'll be working on iExcel. You'll be doing the starred questions in iExcel, and I will be checking to see on that day if you did it or not. That's how you will get credit for the day. And then Friday, we're either going to be going over measurements, or I'll do reviews on 8.3. Haven't decided that yet. That's a little up in the air still. Okay, so let's get to our builder. Here we go. Builder 10 is our homework for this week. So let's look. I want to go through 2 sections on Builder 10. And the first part is this CF and GF. Remember last time you had an example of it. Now you have the question of how to do it. So find the common factors, and greatest common factors of 12 and 48. So if I'm looking at 12, well, that's 1 times 12. 2 times 6, and 3 times 4. Okay, if I'm looking for the factors that make up 48, that's 1 and 48, 2 and 24, 3 and 16, 4 and 12, and 6 and 8. Kind of ran out of room right there, squeezing them together. So what do they all have in common? Well, if I look, they have 1, 2, 3, 4, 6, and 12. So 1, 2, 3, 4, 6, and 12. And of those numbers, the greatest one is 12. Okay, I want to look down at the multiple representation box, because the process is a little different than what we're used to, okay? So it says y equals 10 minus 3x. Okay, normally we've been seeing the variable in the front. Now we see the variable in the back. But it's fine, because all we have to do is plug our number in and solve it. So the first thing I always like to do is I like to go ahead and substitute and fill in the whole process box. So y equals 10 minus 3 times 0. Y equals 10 minus 3 times 1. Y equals 10 minus 3 times 2. And y equals 10 minus 3 times 3. And again, I get my x, the number for x, over here in the x column. So 3 times 0 is 0. 10 minus 0 gives me 10. 3 times 1 is 3. 10 minus 3 is 7. Guys, I'm going to multiply first, because order of operation says I need to multiply before I subtract. So 3 times 2 is 6. 10 minus 6 gives me 4. And 3 times 3 is 9. 10 minus 9 is 1. So then I have my ordered pairs. I have 0, 10, 1, 7, 2, 4, and 3, 1. Now I'm going to plot my points. Now 10 is not on the map, but I can kind of go a little bit above that 9 to figure out where 10 is. Over 1 up to 7, over 2 up to 4, and over 3 up to 1. So I have my points plotted. Now I just draw my line to connect the dots. There we go. And I always like to make sure I put an arrow at the end to show that that function continues. That function continues right there. Okay, so that's Builder 10. That's our builder for the week. I put that to the side. And again, I said that we have 2 sets of notes today. Where did my notes go? They're right over here. So additive and multiplicative relationships. We've got this one, and then one that looks like this. It says graphing, adding, and additive and multiplicative relationships. So the one that looks like our regular notes is going to go on the left side. And the one that's just the page is going to go on the right. But what I want you to do on the right side is I want you to fold this up and hold it like that and make sure that that graphing underneath there, and you see my word problems right there. So I'm going to just close it and then glue it toward the top. And glue it toward the top. There we go. All right, so we're going to flip it on over. Oops. And today is 11/2/2020. And let's get working. So, discovering additive and multiplicative relationships. So basically in this section, we're going to be looking at tables and figure out what did you do to one to get to the other. Okay? Now, there's two ways you can do this. It can either be additive or multiplicative. Well, you're saying that there's 4 operations, Ms. Delcambre. Well, additive can either be adding or subtracting, because adding a negative is the same as subtracting. So additive can be both adding or subtracting, but we just call it an additive relationship, like you're adding a negative, so literally you're subtracting. Multiplicative relationships, well, that's a multiplying and or dividing, because multiplying by reciprocal is the same as dividing. So that's why they gave it additive and multiplicative relationships. So let's look at my question. Every state has 2 U.S. senators. The number of electoral votes in a state has is equal to the total number of U.S. senators and U.S. representatives. So the number of electoral votes is blank the number of representatives. Well, first let's fill out this table before we go back to this. Then we'll go back to that. So we've got to ask myself, what did you do to 1 to get to 3? Well, let's see. Okay, 1 times 3 gives me 3. Does that rule work? Well, 2 times 3 gives me 6, not 4. So that doesn't work. Well, 1 plus 2 gives me 3. 2 plus 2 gives me 4. Okay, so that works. So then that must be my rule. So we need to add 2 to each time. 5 plus 2, well, that gives me 7. 25 plus 2, that gives me 27. And 41 plus 2 gives me 43. So the number of electoral votes is 2 more than the number of representatives. So describe the rule. The number of electoral votes is equal to the number of representatives plus 2. So if we wrote this out as like an equation and with words, we can say our electoral votes is equal to representatives plus 2. So basically I took this and wrote it as a equation right there. Let's look at our next one. Franny orders 3 DVDs per month from her DVD club. Complete the table. So again, let's see if it's additive or multiplicative. Well, if I'm looking at per month. And think back to Brady the Math Cat, per with rates. You knew we were multiplying. 1 times 3 gives me 3. 2 times 3 gives me 6. 4 times 3 gives me 12. 13 times 3 gives me 39. 22 times 3 gives me 66. So the number of DVDs ordered is equal to the number of months times 3. So if we wrote this, we can say DVDs is equal to months times 3. So if we're looking for the what operation we use for the table A was additive, and B was what we multiplied, so this was multiplicative. Okay, let's look at our next part. So before we do our next part, the question, I want to show you with a graph. So I'm going to draw 2 coordinate planes, which are easy. Draw a horizontal line and a vertical line. Bam, made a blank coordinate plane. Do that over here. Now, in this column this little section over here, this we're going to work is additive, making this one multiplicative. And I'm going to draw some lines, and I'm going to show you which one would be additive and which one would be multiplicative. Okay, I'm going to grab my straight edge. I'm going to grab a blue right here. This line right here would be considered an additive relationship, where this one over here would be considered a multiplicative relationship. Okay, I'll do another one. This one over here would be considered an additive relationship. Where this one right here would be a multiplicative relationship. Just looking at the graph, okay? Okay, I'm going to draw one more line. This would be an example of an additive relationship, where this would be an example of a multiplicative relationship. Now I want you to pay attention. Do you see all the lines went through the point of origin in the middle here? So multiplicative relationships go through go through 0, 0, which is also called your origin. Additive relationships do not. Additive relationships do not cross or do not cross 0, 0 or origin. And that is because any number times 0 is always going to be 0. Therefore, I know that this is multiplicative. Here, if I multiply by 0 by 5, I get 0, but then add 4, or 0, 0 plus 4. Well, any number plus 0 is going to be that number, so I would go up and down on my y-axis. So that's a way you can visually see and just tell right off the bat if it's going to be additive or multiplicative. Okay, so here's our question. We have Jolene, and Jolene is packing her lunch for school. An empty lunchbox weighs 5 ounces. Graph the relationship between the weight of the items in Jolene's lunch and the total weight of the packed lunch kit. So make a table relating the weight of the items to the total weight. To get the total weight, add the weight of the empty box to the weight of the items. So before Jolene even opens her box and puts anything in it, her lunch box, she has 0 items in it. So if she weighs it open with nothing in it, it's going to be 5 ounces. Okay. Now let's say she put in some fruit snacks. So we'll say she put in fruit snacks. And those fruit snacks weighed 1 ounce. So then she weighs her lunch kit, then it would be 6 ounces. So say she put in her fruit snacks and chips. So her fruit snacks again weighed 1, then we're adding her chips, maybe they're 4 ounces. So then she has a total of 5 ounces of food, but her lunch kit, we gotta include that. So her lunch kit weighs a total of 10 ounces. So let's say she has the fruit snacks, she has chips, then we throw in a sandwich. All right, and sandwiches normally are heavier than chips, so let's say it's 5 ounces. So 5 ounce sandwich, and then we got to put in her chips and fruit snacks, which she would have 10 ounces. Plus the weight of the lunch kit gives a total of 15 ounces. Okay. Then don't forget we got to give her something to drink. So she has her fruit snacks, she has her chips, she has her sandwich. Now she's going to have her drink. And let's say she has a box of Hi-C fruit punch. And that probably weighs about 5 ounces. So now she has 15 ounces of food and drink in her lunch kit. And her lunch kit weighs 20 ounces. So each of these items then will become an ordered pair. Your weight of the items is your independent variable. I want you to put independent. I-N-D-E-P-E-N-D-E-N-T. Do you know what that means? Okay. And then your total weight depends on how much you put in. So this is what we call our dependent. Okay. So our independent variable will always be X. And X always runs left and right. The total weight is dependent, which is your Y-axis, which goes up and down. So in an ordered pair, we have X, then Y. So let's just order pairs, X, then Y. So looking here, we have 0, and then 5, and 1, and 6, and 5, and 10, and 10, and 15, and 15, and 20. Okay, now we are writing our graph. We're creating our graph. Now, one second. There we go. All right, so we need to label our graph. So my weight of the items, that's my independent variable, which is X, goes on the horizontal line. So I'm going to write weight of items. Okay. Now my total weight's my dependent variable, which is going to go on the vertical line, which is the y-axis. So I'm going to write total weight here. Okay. Now I need to label it. Okay, so I have 0. So I'm going to go, this is 0. Now I'm going to go by 5s. 5, 10, 15, 20. Okay. And I'm going to go up in groups of 5. 5, 10, 15, 20, 25. Now, I'm trying my best. If I had grid paper, it would be perfect. I don't, but it's fine. So I know for a fact at 0, I'm at 5. Okay. Then at 1 ounce, which would probably be about here, would be 6. Now, remember, guys, when you were doing your plotting of your longitude and latitude, you kind of have to kind of guesstimate if there's no lines. So then I have 5 and 10. I have 10 and 15. And I have 15 and 20. So when I connect my dots in the best way possible, there we go. And do you see that this would be an additive relationship because it does not go through the point of origin. Does not go through 0, 0. And I was adding 5 each and every time. So this is an additive relationship because you're adding 5 to the weight. And also visually, it does not go through the origin. So that's important, this part right here. It does not go through the origin. That makes it additive. That makes it an additive relationship. Okay? So your homework tonight is 8.1. I'm going to come over here and grab it. Give me one moment. Okay, and go ahead and eliminate number 3. So I went ahead and eliminated number 3 in my 2 virtual classes. All right, so let's look at question number 1. Complete each table. Tell whether it's an additive or multiplicative and give the rule. Write the order pairs and graph them on coordinate plane. Okay, so Jeff rents 6 movies per month. So think to yourself, well, what did you do to 1 to get to 6? Okay, well, you're either multiplying by 6 or adding 5. Okay, well, what did I do to 2 to get to 12? Well, that was multiplying by 6. So my rule is multiplying by 6. So 5 times 6, well, that gives me 30. 17 times 6 gives me 102. And 32 times 6 gives me 192. All right, so this is a multiplicative rule. Okay, my ordered pairs are 1 and 6, 2 and 12, 5 and 30, 17 and 102, and 32 and 192. Okay, when we graph, my months is X, my movies is Y. So months is going to go down here, and movies is going to be on the Y axis. Now, I don't need to go all the way to 32. As long as I have 2 numbers or 2 dots on a graph, I can make a straight line. So there's some I will not need. I don't need 17. I don't need 32 because there's no way I can do this. But I could do 2 and 1 and 5. So my months, this is going to be 0. I'm going to skip 1, skip 2, skip 3, skip 4, skip 5. Okay. And then because I'm going in units of 6, I'm just going to go in units of 3 going up. So 3, okay, so 3, skip 6, skip 12, skip 18, skip 24, skip 30, skip 36. Okay, now if I'm plotting my points, I have my area to plot. Well, over 1 up to 6, over to 2 up to 12, Okay, over to 5, up to 30. Let me make sure I go to the line. Okay. Now, because this is multiplicative, it's going to go through 0. So it needs to start at 0 and it needs to go up. And you need to put an arrow because that function continues. Okay. So that does it for today. Tomorrow we're going to be going over a little bit more of this, looking more into tables and graphs and identifying your rule of what's going on with them, and looking at more tables and graphs, and also looking at map keys and looking at the key and how that is related. Okay, so have a great day. I'm glad, hopefully everybody was safe this weekend and had a nice weekend. It was beautiful. And I will talk to you later. Bye.